Alright, this video continues on our topic of polynomials and working with polynomials. Today we're going to look at combining like terms. So in order to do that, remember we need to recall the definitions that we've been learning so far. We need to remember that each algebraic term might consist of coefficients, variables, and exponents on those variables. So we need to be clear on what each part of that is. So for example, if I wrote out 3x squared, make sure you are able to identify each component of this term. So this 3 would be the coefficient, this x is the variable, and this 2 is the exponent on that variable. So make sure that you're able to identify that. Okay. The blank here is like terms. Okay, like terms are terms that differ only by their numerical coefficient. This means that the variable and the exponent of each variable is identical. So for example, we could have 3x and negative 2x. The only difference between these two terms, right, is this numerical coefficient. In fact, the numerical coefficient could be the same. The important part really is the part that makes them like terms is the variable. The variable needs to be the same letter, so in this case both x, and it also needs to have the same exponent on it, so in this case just that little 1 on each of them. Okay, if that's the case, then they are in fact like terms. Okay, so do another example here: 4ab and negative 2ab. Okay, these would be like terms because again, the variable part of it, they both consist of an a and a b. The exponents on those a and b are also the same. Okay. And one last set that you can look at here is 4x squared and 2x cubed. Okay. Is that a set of like terms? Well, no, actually it is not, because this 2 is different than the 3, so this is not a set of like terms. Okay. Now, why do we bother? Well, there is an important rule here. Like terms can be combined, unlike terms cannot be combined. Okay? It's kind of like the analogy of apples and oranges, right? You are given 3 apples and 4 oranges. What do you have? Well, you have 3 apples and 4 oranges. You can't really combine them together any differently than that, right? You're basically limited by describing them as separate terms. You can't combine them anymore. Okay, so when we do have like terms, they can be combined. How do we do that? Well, we're going to look at 2 different methods. The first one is using algebra tiles. So you are going to, in order to do this, use algebra tiles to represent each term. Okay, so remember we looked at algebra tiles last time. Hopefully you're familiar with that. You know the different what the different shapes represent, and when they're shaded in or when they're not shaded in, being positive and negative. Make sure that you review that if you're unsure. Okay, you're going to group the tiles to form what we call 0 pairs, and I'll show you examples of this. Once you have 0 pairs, then you are able to remove them. Anything that stays at the end, the remaining tiles, you can then write an expression. Okay, so let's look at an example of how we can do that. So you are given 4x minus 2x plus 3 minus 6. Okay, so if you were going to combine the like terms here using algebra tiles, you would draw out all of these things. So 4x I would draw out, it's positive, right? So I'm going to color it in. Okay. 4x. Okay. Then I'm going to draw in negative 2x. Okay. I will then draw positive 3 ones. Okay. And negative 6 ones. Okay, and you'll start to see that as you do this, it might be advantageous to draw them in a certain pattern. I'll show you what you mean. The second step, remember, was to group the tiles to form 0 pairs. So basically, what we mean by that is you are going to match up any positive and negative, right? If we add a positive 1 and a negative 1, those cancel out. So I'm going to attempt to draw little circles around pairs that are 0. So I just did that. That cancels out, right? That's going to equal 0. Okay? I'll draw the same thing around this one. Okay, that's going to cancel out. I can cancel out. I have 3 positive ones here. I'm going to cancel those out with 3 negative ones. Okay, that cancels off. Those are 0 pairs. If you have equal number of positive and negative, they cancel off to equal 0. That's what we mean by 0 pairs. We remove those. We cancel them off. Okay. Then simply we write an expression for what's left over. So we count out, well, we got 2 of those left, and we've got 3 of these left. Okay. So what do we have? We have 2 positive x's tiles. So we have 2x, and we have 3 negative 1 tiles. So we can write that as minus 3. So overall, no, that's not very clear. I'll rewrite that. Okay. After we've combined the terms, we are left with 2x minus 3. Okay, so the method is a little more visual. Maybe you're able to see better what's going on. We'll quickly show you another example that'll get you to do on your own using this, and then you'll be able to show me in class tomorrow. Okay, so I'll write out, again, you're going to do this using Algebra Tiles. Combine the like terms for 2x squared plus 3x minus 1 plus x squared minus 4x minus 2. Okay, so again, same method, right? Draw out the algebra tiles for each term, group the 0 pairs, get rid of any 0 pairs that you can. Anything that's left over is going to be part of the answer. Okay, so do that for a minute. If you need to pause the video, do that right away so that it's fresh in your mind, and I'll take a look in class then to see that you're able to do that. Okay. Method 2 probably eventually becomes faster. It's good to start with the algebra tiles, but eventually probably get to the point where you're going to just use algebraic symbols. So basically what that means is we're going to add or subtract the coefficients. Coefficients of like terms. Okay. Now an important note here that is going to make it easier for you is that polynomials can be written in different orders as long as you maintain the sign that comes right right before each term, the plus or the minus. You can switch around the order of it. Sometimes it makes it easier to combine like terms if you rearrange that polynomial with the like terms close together. So we'll do a couple examples and I'll show you what I mean with that. Okay, so first example, I want you to follow along here. We're going to use the second method here. We're going to combine 4x minus 2x plus 3 minus 6. Okay, so this is the same example we did before. Notice how the like terms are linked together, right? 4x and negative 2x are linked together. They're right beside each other, and then the positive 3 and the negative 6 are also like terms. We're going to be able to combine, so I write them right beside each other. Okay, and very simply then you add or subtract the coefficient. So the coefficient on this term is 4, coefficient on this term is negative 2, so I combine 4 and negative 2. That's going to leave me with 2, and we keep that same variable part, so 2x, and over here I've got the 3 and the negative 6. I just combine those, so that it ends up being negative 3. So very simply I've got 2x minus 3. You can go back and check that's exactly what we got last time. Okay, we'll show you one that maybe you got to do an extra step on. Okay, so 2x minus 6 minus 2x plus 1. Okay, so again we're going to identify the common or the like terms. Okay, this 2x and that negative 2x are common. Okay, and then we also have this negative 6 and positive 1 that are common. So here's where I would say it's probably easier to rewrite this with the common terms together, the like terms together. So I'm going to rewrite it as 2x. I keep this negative sign and write negative minus 2x, and then I write the other sets of terms on their own, minus 6 plus 1. Okay, now I've put it together, it's going to be easier for me to maybe see what's going on, and I combine. So 2x minus 2x, I combine the coefficients, so 2 minus 2 is 0, so I have 0x. Okay, minus 6 plus 1 gives me minus 5. Okay, now the 0x, 0 times x is just 0, so I don't even need to write that. The overall answer is just going to be negative 5. Okay, I got one more for you that I'll get you to do on your own, and I'll check it. Okay, k minus 2k squared plus 3 plus 5k squared minus 3k minus 4. Okay, so do that one on your own, combine the like terms using this second method of just algebraic symbols. Okay, hope that was helpful. Thanks.